might have seen it. This example, it is similar to your assignment 1, but it is not the same. It is similar to your assignment 1, but it's not the same. So it says find the current in all circuits, or in all the circuit resistors below using total resistance and voltage drop. Do not use current division rule. So they've given us, they say we should find the current in all the resistors in the circuit, all the resistors. So find the current here, current here, current here, current here, in all the resistors, but we shouldn't use current division rule. So they've given us an omission. They said we shouldn't use current division rule, and since they said we shouldn't use current division rule, I'll first of all use our simulations to solve this our circuit. The voltage source here is 25 volts. The voltage is 25. So using our simulation, we realize that when the current starts to flow from here, the 8 ohm and the 10 ohm are short circuited. They do not receive. There's a short circuit here. You see that the current just take this path, then it comes back. So it gets here, a split, comes here, then also here a split, and it just take this path and come back. The 8 ohm and the 10 ohm doesn't receive any current, so we take it out of our analysis. Then our circuit now becomes this. So finding it, we realize that, you see, you see that the current through this resistor, all the values are shown here. The current through this 1.67, the current through this 1.67. You see that this 1 and 5 are in series. So the total current, the current through the 2 ohm resistor is 7.5, and basically everything. So we need to now confirm this answers the simulation has given to us, and to confirm it, they said we should use KVL and total resistance and the concept of voltage drop. We shouldn't use what do we call it? We shouldn't use current division rule. So to start with, finding the total resistance. So to find the total resistance, we realize that this and this are in series. The 1 and 5 are in series, so we can simply add them. After adding them up, we realize that the 6, this now becomes 6. 6 and 3 are in parallel. So 6 and 3 are in parallel. After resolving them, we get 2 ohms. And after resolving the 2 ohms, the 2 ohms now comes here. We clean this and we now write 2 ohms here. And we realize that the 2 ohms and this 4 are in parallel. So we also resolve that. So after resolving that, we get 4/3 ohms. After getting the 4/3 ohms, we can now clean here. And we'll now only leave this side. So here now becomes 4/3. Then we realize that the 4/3 and the 2 are in series. So we simply add them up to get 10/3 ohms. So our total resistance in the circuit is 10/3 ohms. After finding our total resistance, we need to find our total current, and our voltage they gave us was 25 ohms. So we simply use Ohm's law. V is equals to IR, and the IT is now equals to V over RT. So this now 25/10 over all over 10 divided by 3, which gives us 7.5 amps. So now it tells us that 7.5 amps flows through here, and from our simulation, if you remember, when we brought our cursor here, it was showing us that 7.5 amps. So we now need to calculate the voltage drop in this 2 ohm resistor. So to find the voltage drop is simply the total current multiplied by the 2 ohm resistor. So the total current is 7.5. So the 7.5 by times the 2, it becomes 15. So after getting our 15, we subtract it from our total current, our total voltage. So subtracting it, we realize that we have 10 volt. So meaning at this node, 10 volts leaves here. So meaning, and resistors in parallel, what did we say? We say the same voltage flows across them. So here is 10 volt, meaning here the voltage drop here, the voltage drop at this node was 15. In this resistor was 15. So at this node, meaning the voltage that will be leaving this place, so 25 minus 15 becomes 10. Voltage that will be leaving this junction is 10. So 10 will be here, 10 will be here, 10 will be here, because it's this voltage that will here, this same voltage that will appear here, this same voltage that will appear. So basically, to find the current through, we now need to now find, since we now know the voltages that are living here, we now know the voltages that are living here. So now to find the current that the various current of the various resistors. So here, let me just write it here. So we have our 10 here, our 10 here. So now to find the current, so I'll name them current through the 2 ohm resistor. So to find the current through the 2 ohm resistor is simply our 25 divided, that is the total current, because it is the total current that will flow through our 2 ohm resistor. So 25 over 10 divided by this is 7.5 amps. But the tricky part now comes here. Current through the 4 ohm resistor here, this 4 ohm resistor, you see this is the voltage across it, and the current is simply equals to voltage over resistance, and the voltage here is 10 and the resistance here is 4. So basically we just divide this, the 10 over the 4. So the current through the 4 ohm resistor is 10 divided by the resistance 4. So 10 over 4, which is 2.5 amps. And the current across the 3 ohm resistor is also 10 divided by 3. So 10 divided by 3. So current through the 3 ohm resistor is equals to 3.33 amps. And finally, the current between, we realize that this 1 and 5 are in series, so we can just add them up, because the same and what did we say, in series resistor the same current flows through them. Series resistors, the same current flows through them. So we can simply find it. So it becomes 10 divided by, so the current through I1 and I5 is equals to 10 divided by 6. We simply add them up, so to find it. So when we divide 10 by 6, you get 1.667 amps. So basically this is how we find resistors, we calculate resistors in the current through the various resistors. And this so far will really, these questions, I know these questions really test your understanding on all the concepts we've learned so far in class, and kindly take your time to watch this video very well. If you don't understand anything, just leave a comment.